I have that pleasure to open one of the closing sessions of this our first day of the Emerge 2022 conferences. Today's topic will be AI in practice. My name is Vera Mevora. I am a research fellow here at the Institute for Philosophy and Social Theory, Digital Society Lab, and I will be your chair. So with us today, we will have 4 presentations. I will say for your introduction only titles, and then I will present the speakers as they will give you their presentations. So we will have a presentation about artificial intelligence models for prediction on mental distress from social networking addiction indicators, about identifying the face of populism with computer vision, a deep learning approach to emotion recognition, next generation user interface for a vulnerable group of users, and collective knowledge building in online social networks. So a very diverse number of topics which we wanted to bring together at this session and to just see how is AI actually put in practice in diverse fields. So without further ado, I want to give the word to our first speaker, Igor Pantic, who is here in front of a larger group of authors from the Faculty of Medicine, University of Belgrade. And he will give us a presentation on the topic of artificial intelligence models for prediction of mental distress from social networking addiction indicators. Igor, please. Yeah.
Okay, so thank you very much to the organizers for the kind invitation. I'm really honored and pleased to be here today and to give this short talk about the possible application of machine learning and artificial intelligence in my area of research. I am, by the way, a medical doctor and a psychiatrist, so I'm not really a social scientist, and I have some programming knowledge and knowledge in terms of artificial intelligence, but when it comes to social sciences, much of that expertise comes from psychiatry, not actually psychology or sociology. This is really a multidisciplinary topic which is applicable everywhere. But when it comes to psychiatry, application of artificial intelligence is relatively rare. Although in medicine in general, that is not the case. Today we have a lot of machine learning platforms, machine learning programs that are used for classification, for prediction of various medical phenomena. And you have hospitals in which, for example, you have machine learning programs that can predict the diagnosis from the symptoms. But when it comes to psychiatry, you don't have that kind of application. It's relatively rare, but it is really an exciting topic, and it has a huge potential in psychiatry. Probably psychiatry will be the last field in medicine that will be overtaken by artificial intelligence. Radiology will be the first, then dermatology, and psychiatry probably the last. But when it comes to research, it's a really an exciting thing. What my area of research in the past 10 years has been is social media addiction and internet addiction as a phenomenon. It's not really a psychiatric diagnosis. I cannot give that F diagnosis to someone because he's addicted to social networks or his mobile phone. But that is definitely a phenomenon that exists. Every psychiatrist will tell you that. And it causes a great public health concerns. It is associated with significant mental distress and depression and anxiety. And there are really numerous studies that says that the more that you're addicted to your phones and to your social networking platforms, the more probability you have that to develop depression or anxious disorder. And that all comes basically from mental distress that is associated with that addiction. So having in mind that, we actually wanted to create here a machine learning models, or to propose hypothetical machine learning models that would be able to theoretically predict the level of mental distress based on social media addiction indicators. There are various possible indicators. We conducted a separate study for this. Sorry. So the data was taken from an existing research that we have done in a project that was approved by the Institute of Philosophy and Social Theory and supported by the Open Society Foundation. And hereby I would like to thank the Open Society Foundation for the support. So we conducted a cross-sectional study on 500 young people in Belgrade. When we say young people, we mean from 18 to 30 years old. And we used a structured questionnaire to determine the data on internet addiction, on social networking addiction, and also on mental distress. So the tools that we used, basically in that questionnaire, we had a set of questions that are basically copy and pasted from the existing diagnostic criteria for substance abuse. For example, alcohol or heroin or cocaine, but converted to be more applicable for behavioral addictions, for social networking and internet. For example, the craving to use social networks, that was the one question. The other question is neglection of work, school, and family obligations, and also the loss of control, and continuing to overuse social media despite the clear evidence that it is harmful. And we also examined the number of hours they spend on various social networking platforms. And that was the input data for possible prediction of mental distress. How actually we measure chronic mental distress? We measure it by using a depression, anxiety, stress scales. It's a very common questionnaire that can quantify anxiety, it can quantify depression, it can quantify also chronic mental distress. It is not usually used in psychiatry. For example, when I want to make a diagnosis on depression or mental distress or whatever, it's basically my personal subjective opinion. We don't give this. This is only for research purposes. And that was the output for the machine learning models. So what we actually did, we trained different models based on decision trees, on random forests, support vector machines, binomial logistic regression algorithms, and we also proposed the creation of neural networks that were based on multi-layer perceptrons. And the results, those initial results that we have obtained, they show that some of those models, or most of those models, have relatively good classification accuracy, higher than 70% when it comes to predicting mental distress, whether it is elevated or normal. So it's not ideal, it's not excellent, but it's not actually useless when it comes to prediction. Whereas and subjective observers, for example, a psychiatrist, it's almost impossible to predict mental distress from any of those parameters. So this is just an example of a proposed neural network. It's a multi-layer, a very simple multi-layer perceptron that has 2 hidden layers and 7 neurons in the first hidden layer and 3 neurons in the second hidden layer. And so the output is either the stress that is elevated or that the stress is normal, while the input are all those scores that we obtained from those questions. Random forest, we can create it by using various methods. The methods that we used is based on scikit-learn library. It's a Python library, and it's a relatively simple piece of code. You don't really need to know a lot of programming language to develop it. And we had the area under the ROC curve of 68%, which is not very good, and the estimated classification accuracy about 70% of this model. So what are the limitations of this study, of this research? For example, bias. You always have bias whenever you have a cross-sectional study, information biases and other biases. It's a small sample, so 500. It's enough to propose a hypothetical model. It's not enough really to make a model that is useful in practice, but this is a starting point for some future research and for obtainment of future data. So we actually didn't use the available data from the internet. We collected our own data on a relatively homogeneous sample, and that's the strength of this study, but the limitation is obviously the limited sample. Is it practical? So is it useful for me in practice? Well, yes or no. Mental distress is very hard to predict when it comes to psychiatry. So I don't have any special powers as a psychiatrist to say that someone is under stress or not. Someone who is under a lot of stress may simply mask it and simply decide not to tell me that. But people who are addicted to internet and social networking, when they come to my office, they say it. They answer honestly those questions if they have this kind of problem. So it would be really useful to have a model, an application, for example, that would be able to tell me whether the person is under stress or not, because from that I would be able to make a conclusion. For example, what is his risk for developing, for example, depression or anxiety disorder or something else. So the conclusion, our finding is a potentially valuable foundation for future development of powerful artificial intelligence sensing systems capable of prediction of mental distress from social networking indicators. Of course, this is just a preliminary study. It's just a starting point on which we will develop some other research. So again, thank you very much for your attention.
Igor, we have a little bit more time. If there is something you maybe think it's also important, you something want to add?
Yeah.
Potential.
Well, when it comes to future research, we will use internet data. So there are really a lot of different studies that try to connect, to relate social networking abuse and addiction to psychiatric phenomena and diagnosis such as depression and anxiety. So it would be interesting just to merge this data with the available data sets that you have, and there are a lot of data sets on the internet, and to see whether we can really make a model that will be able to predict not only mental distress, but also depression and anxiety based on certain social networking indicators. So that's just a plan for the future research.
Thank you very much. So we, as I promised, the presenters today are going to discuss very different topics in very different fields. So we go to our colleagues from the Faculty of Philosophy, University of Novi Sad, Sarah Major and Alexander Tomašević, who are going to talk about populism. Their topic, the title of their presentation is Identifying the Face of Populism with Computer Vision, a Deep Learning Approach to Emotion Recognition. Please.
Thank you for the introduction. I'm grateful to have the opportunity to share what we've been working on. Thank you. So I'm grateful to have the opportunity to share what we've been working on with all of you. For the sake of not wasting any time, I would like to get started immediately. So our research primarily deals with computer vision, and we were interested in seeing how computer vision could potentially be used as a tool for social scientists to conduct visual research, which is not very common, and how it would perform in that realm. So especially when it comes to face recognition and emotion detection. To do this, we started off by taking populism as a sort of case study. Populism has most often been characterized as this deeply emotional political movement, and it's often been associated with negative emotions. So in media, you'll often see populists accused of inciting inciting anger or anxiety, fear among the voter population, so among voters. And on the other hand, you'll see in scientific research on the matter, there is this kind of the same narrative. So populists or the populist movement is often found to be associated with negative emotions in the existing research. However, even though this is the case, a large portion of the existing research on populism has found these associations or these links between negative emotions and populism. A lot of them have sort of been based essentially just on exclusively text. So they've been kind of underutilizing this large amount of visual data that is available out there. And we essentially wanted to see how a visual analysis of populace would hold up when compared to this vast amount of text data or text-based analyses that exists out there. Up until recently, analysis of facial expressions was done manually. So it was not only a very difficult process, it required a lot of training and a lot of skill, but it was also an incredibly time-consuming process because it required the human coders essentially to code every image manually, which could be very, like I said, a long process and very difficult to actually do a large amount of data for. So our main objective was thus to find a way to use computer vision to analyze and compare the facial expressions of emotions among populist and non-populist leaders using an automatic detection of emotions. So when it comes to the automatic detection of emotions or automatic analysis, visual analysis, there are essentially two problems, two computer vision problems. The first is face detection, and the second is emotion recognition. So for this purpose, we implemented an existing neural network that was trained on a low resolution, so very low resolution grayscale images of faces based on the FER 2013 data set. This is essentially the FER package in Python. And it is actually based on two previous implementations. So one is the MTCNN for face detection, and the other one is the mini exception model for the PAZ library, which is used among other things for also emotion detection and recognition. When it comes to accuracy, the FER package, let's see if we can. Yeah, when it comes to accuracy, so in detecting and classifying emotions, the FER package has an accuracy about 66%, which although it isn't close to perfect, it isn't bad for a start. And we wanted to see how it would essentially hold up when implemented on a given data set, so on a given sample. To construct our sample, we chose 11 countries. So this was a bit of a complicated process. We chose 11 countries, taking three parties per country, with the exception of the United States due to their essential two-party structure, and then taking one leader per party. This gave us a total of 32 political leaders. And of those 32 political leaders, we took 5 videos from YouTube for each leader. So we took YouTube videos that were from either their own official YouTube channels or the official YouTube channels of their parties. And an important footnote to that is that we also excluded any videos that were in any way modified by third parties like news outlets. So any kind of press clippings and interviews were excluded because they held the possibility of or the risk of being modified in a way that wouldn't be true to their own, like the self-representation of this leader. So we decided to exclude that for the sake of seeing how they choose to represent themselves rather than how other people choose to represent them. So this whole process gave us a total of 160 YouTube videos. So it is quite a small sample. Of that, 75 videos were representing non-populist leaders, while 85 were representing populist leaders, and 400 frames were taken for each video. Once the videos were run through Python, the FER package returns averages of 7 emotional states. So we can see them listed here. They're anger, disgust, fear, happiness, sadness, surprise, and a neutral expression. These are the 6 or let's say 7 universal emotions that we have from psychology. So from Paul Ekman, it is essentially based on the facial action coding system developed by Ekman. And just let's see if this is working. Yeah. So to show some examples, on one hand, we have. So on one hand, what the FER package does is it gives us averages of these 7 emotions for each video within the sample, and it also gives you insight into each selected frame from each selected video. So we're going to look at a few of these examples here, starting off with a neutral expression. We can see this is like it's like a very base level neutral expression. So these are frames from our sample in which neutrality was the dominant detected emotion. On the other hand, in this case, we have images or frames from selected videos of anger and sadness, respectively. So these are frames in which anger or sadness were the dominant detected emotions in each frame of the video. One of the important things to mention here is that usually most of the time, the detected emotions will not be a clean emotion, like a clean expression of emotion. So very rarely will you see a frame in which only one emotion is detected. So usually it's going to be a mix of several emotional states. That is, on one hand, due to the fact that humans very rarely have very clean emotional expressions, and on the other could be a matter of detection issues with the program. So we have, like I said, we have anger and sadness. They do not look very, very happy. On the other hand, we have two examples of, where am I pointing this? Sorry, can we get the next slide?
Try it. Yeah.
Sorry? It's,
Are you pointing?
I'm trying to. Oh, wait, yeah, there we go. Okay. So on the other hand, when we look at this example here, up here, we can see two examples of the two gentlemen in the upper left corner, two examples of what would be considered a clean expression of emotion. So the proportion, the detected proportion of happiness is equal to 1, or essentially there is no other detected emotions within this specific frame. On the other hand, again, on the right side, we see a few examples of mixed emotions in which fear would be the dominant one. This could, so on one hand, be a matter of, again, whether these emotions are more easy for the program to detect. And on the other, it could be a matter of these clean expressions just being more common in real life, or easier to like tell apart from other expressions. Okay, lastly, two emotions which were least commonly, not very commonly detected, are surprise and disgust. And disgust is a particularly interesting case because on one hand, it is not often detected. And on the other hand, even when it is often the proportion of detected disgust is most often very small. So here we have in this image a staggering proportion of 0.23, which is again still not the highest. It's not even the highest dominant. It's not the highest or the dominant detected emotion in this given frame. We could argue whether this is a face of disgust. I personally don't see it. Maybe you do. We can agree to disagree. But like I said, so this could be a matter of either the politicians in question not expressing disgust to a certain degree due to them not wanting to include that in their own self-representation, or on the other hand, it could just be a matter of the program isn't good at detecting disgust. On to results. So there we go. On to results. We found a statistically significant difference between the group of populist and non-populist leaders, or the groups of populist and non-populist leaders, with a higher proportion of negative emotions being associated with a higher degree of populism. So the negative emotions are anger, fear, disgust, and sadness. The sum of them was found to be positively associated with a higher degree of populism. If we look on the x-axis here, so 1 on the x-axis represents strongly non-populist leaders, while 4 represents strongly populist leaders. And we can see that this is like a very linear sort of relationship between these two factors. Then here we have insight into anger and sadness. They were specifically found to be the most relevant or statistically significant for the group of populist leaders. And discussed, again, because it appears not very often in the sample. The proportions are quite small. It wasn't found to be statistically relevant at all. Sadness, interestingly, was found to be, not sadness, sorry, fear was found to be statistically relevant for the group of non-populist leaders. So that was something that should be taken into account when looking at the results of this research. Lastly, if we look at the proportion of other expressions, so neutrality, happiness, and surprise, emotions that are not considered negative, we can see that they have a stronger association with lower degrees of populism, or rather with non-populists. And this is it kind of also makes sense when you look at the given theory surrounding the populist or non-populist performance or relationship with the audience, whereas non-populists tend to or are theorized to have a more neutral approach, so a more conventional approach in their communication with voters. They tend to present themselves as, let's say, more put together, maybe more distant, more reserved. So them having a high proportion of neutrality, especially in the strongly non-populist group, is kind of expected given this approach. Yeah, I'm concluding. So here we also have the surprise and happiness. Again, we see that the second group is more expressive than the first. So these are really just, they don't got a lot of stuff going on with their facial expressions. And lastly, to conclude, so the results of this analysis are, for the most part, in line with previous text-based analyses of populism and its relationship to emotional expression. And when visually analyzed, populism was shown to be associated with negative emotions or negative emotional expressions. These findings point to the notion that the FER library, when done on a small sample, it has shown to be conducive to visual analysis. And obviously there is more to be done. So we should probably validate, there should be done, like, we need to validate the findings of this research on one hand, and on the other, obviously the sample size could be vastly expanded. But this is generally, undoubtedly opens up new avenues for visual research or for research of this area in general. And it allows for a significantly larger amount of data in comparison to manual image coding. So thus it has the potential to proverbially level out the playing field between text-based and visual-based research. I leave you with that. Thank you for your time and attention.
Thank you. Thank you, Sarah. Alexander will also be here for the discussion, so he will also share some of his perspectives. We will move on to the next speaker with us today, Milan Čabarkapa, Faculty of Engineering, University of Kragujevac, with his presentation, Next Generation User Interface for Vulnerable Groups of Users. Milan, please.
Thank you. Just a second to start the presentation.
So while we wait, we have to apologize. So this, what you hear now, it's actually normal for the street we are near. But an hour ago, that was not normal. That was some kind of protest I've never seen before.
It was really a protest.
Yeah,
okay.
yeah. So it was a
I
protest.
thought it's a normal thing.
Okay. So the owners of the private rafts that we have on the bank, the river bank of Sava River, they were protesting the new rules. Thank you for the information, because we all hear that.
I actually thought it's normal.
Maybe usually this one was normal. So just so you can compare. Yeah. Here we go.
Thank you. It's a pleasure to be a part of this conference and
Sorry.
to hear a lot of such outstanding presentations from the early morning to until now. And thank you to organizers for everything. My presentation is related to next generation user interface for different kind of vulnerable group of users. Firstly, I would like to present the results of my previous two projects from Horizon 2020 program. These two projects are related to online protection, cybersecurity, and privacy protection as well, and is part of cascading grants from Horizon 2020 program. These projects are named Children Agents for Secured and Privacy Enhanced Reaction 1 and 2nd. Now there are a lot of content on the internet, and the internet is really useful for the children, but there are many risks. There are risks from inappropriate content. Also, there are a lot of cyberbullying through the messaging apps from on our mobile phone and also on tablets or PC. Also, we are witness of online predators on the internet these days also, and the fourth type of cyberbullying attack is indoctrination. How there are a lot of indoctrination, especially in developing countries, but also in developed countries as well, especially from some ethnic groups in those countries. We can supervise children and also other vulnerable group of users. I will give details later, but we cannot do this all the time. We cannot supervise. They deserve some privacy as well. And our current solution in this direction are based on two types. There are banning particular sites. You can ban some sites, and some users couldn't access the content, and that's it. But you can analyze content on application level as well. Maybe if you try to upload pornography on YouTube, you cannot upload pornography. They have algorithm, but only on application level. But what about several messaging apps? What about social media, social networks? You can send any type of content through this channel of communication. And now internet, there is no full protection, only on some application level, and only if you ban some application, but you cannot do this all the time. Due to that, we could say that there is no algorithms that could analyze text, video, speech, and audio as well simultaneously to find inappropriate content for a vulnerable group of users, especially for children. And in order to develop this kind of solution, we should try to implement new kind of user interface that will be completely application agnostic. And I will talk about application agnosticism during this presentation. What is application agnosticism, and what are the architecture of the solution that we could use in this context? The main goal of our Casper Horizon 2020 project was to identify using of artificial intelligence in this context, how to use artificial intelligence appropriately to protect children and young people on the internet. And we have different kind of work packages to analyze different kind of content, to analyze text, to analyze images, to analyze video and audio, and also speech on our PCs and laptops. We would like to extend our solution to be applicable on hardware limited devices such as mobile phones and tablets, because it is hard to implement artificial intelligence on this type of devices on mobile phones and tablets. It's hard to implement in real time artificial intelligence on this kind of devices. Special challenge is to support collaborative use of this technology while we should preserve privacy of our users. And because of that, we do not process the data on the server side. We process data on client side or on edge computing side, on the level of local area network. And there is no sending data to servers. Everything will be done everything will be done locally or on edge computing level. When we talk about artificial intelligence perspective, we should talk about extreme machine learning. Extreme machine learning in the sense that we could not have enough data to train this kind of algorithms, or you could access some data that is not a part of our previous training, and how to adapt our algorithm in real time on that situation. Because of that, we use some kind of extreme machine learning and transfer learning, how to fine-tune these algorithms in this case. We have 5 milestones in this Casper projects. First, 3 of them are selection of appropriate artificial intelligence algorithm for the text processing, for the graphical content processing, and for audio and video content processing. All how to detect problematic content, and after that, how to prevent this kind of inappropriate data. We have implemented in lab pilot platform and measure some performance in lab conditions as well. There are 4 work packages. First work package within project is related to.
I'm just sorry. You have just 2 more minutes, so you should slowly correct.
Okay, there are first work package is related to how to identify data for the training of artificial intelligence algorithm, and other 3 packages are regarding to the text, to the speech and audio, and also for the images and video. These are the proposed architecture. We are processing on human-computer interaction level the data, and we are capturing audio, text, and images in both directions, up and downloading data and uploading data. Both type of content we are processing, and applied artificial intelligence to different kind of cyberbullying attack. This solution is now piloted, and we need to extend this and try to implement products that could be used in real conditions. These are some project results when we talk about inappropriate pornography, inappropriate content. This is original website, and this is how Casper work. He can cover some part of the screen and protect from inappropriate content. For the future work, we should develop mobile app for Android devices. Also, we plan to implement this solution in 1,000 schools in Serbia and target parents in all Western Balkan countries to try this type of solution. Our next step is to form a team who could develop and who could develop final product to use all these results and make this product available on real market. And team should be, one part of the team should be from engineering, should work from engineering perspective, and other part of the team should be domain expert for social sciences and humanities, because we need this type of experts for the training data, for accessing training data, and to give us some steps how to access all this kind of data for training of artificial intelligence. Thank you all for.
Thank you. Sorry again for cutting you short, but you got there on time in the end.
Thank you.
Okay, so our last. I'm sorry.
The pointer.
Yes, we will get the pointer. Do not worry. Here you go. We're very happy it works now. So our last speaker for this session is Marija Mitrović-Tankulov. She's actually one of the older collaborators of Digital Society Lab, and we're happy to have her here. She comes from the Institute of Physics, Belgrade, University of Belgrade, and her presentation is titled Collective Knowledge Building in Online Social Networks. Marija, the floor is yours.
Thanks. So we talk about artificial intelligence here, but I want to put us a little bit back. So yeah, we use artificial intelligence for many things today. We cannot imagine our life without this. So we use it for recommendation algorithms. We saw image recognition, extracting emotions, both for science and for everyday work. And we are more and more using it for knowledge organization and building. As you know, there are many large language models that are currently used for different kind of things, even for writing papers. So they're not that good, but okay. But there is a lot of questions raising from AI. So it's usually ethics. We heard about biases, and of course there is misuse and abuse of different kind of artificial intelligence data. And you have to keep in mind that your artificial intelligence model or whatever is strongly data dependent. So basically we still depend on how we collect the data, the quality of data, and how broad our data sets are. So this is just one example of how AI can get wrong. So there was an experiment where AI was used to classify wolves and Eskimo dolls. And then they've studied what this algorithm was doing. And actually, they found out that because wolves were mostly, or all images of wolves were on snow, actually it didn't recognize wolves or dogs, but actually it recognized snow, okay? A more complex thing was with COVID-19. So there was a whole group of people actually trying to develop a model that will be able to predict so severity of state of people who got infected with COVID-19. And actually what was found out after the testing different kind of like 232 algorithms, they found out that only 2 of them were still promising to test further, but none of them actually was able to actually detect the person. So for instance, what they found out is that because they didn't have enough data for children, they used, of course, data of healthy children, and then they found out that there are some issues that actually the algorithm recognize some things that are not related to COVID, okay? Or for instance, for severity, they use data of patients that were standing while their X-ray was taken or lying, because usually typically people that had severe situation, they were lying. And then the algorithm actually recognizes whether the person is lying or standing, not the severity of their state. So basically, your algorithm is as good as your data, okay? So it's powerful, but it's not without faults. It's a black box. We actually don't understand what algorithms do most of the times. And what is the most important thing is that they don't provide insights about the mechanisms of the system, okay? So I'm more for combining artificial intelligence with traditional approaches. And I think this will be more valuable and more reliable for us. So let's go back to traditional approaches. So there is a very interesting field that emerges in the past 10 years, I would say. So it's called computational social science, and it actually gets around people from different kind of disciplines. So typically physicists entered this field like 20, 15 years ago. And we provide abstract and simplified models and methods. We also study a lot of complex network data. So we provide methodology for studying these social network analysis. Of course, computer science and data science, they provide algorithms and computational power that allows us to actually extract the information from the data. And of course, social scientists who provide the framework and help us to actually interpret the data in the right way. Okay, so basically this is an initiative that we're doing. And I want to show you what these initiatives can actually help you to understand when it comes to collective knowledge building, okay? So why we are interested as a scientist or as a physicist in social systems, actually social systems are a typical example of complex systems. So this means that they consist of a very large number of interacting entities that exhibit collective behavior, okay? So collective behavior is something that we cannot predict based on the behavior in individual units, but actually the interactions between units lead to this collective behavior, and we have to include this into our analysis. Social interactions are what is important for us, and we actually, what we want to do is to understand and determine the principles that govern the emergence of this collective behavior in these systems. And what we as physicists do, we actually use empirical analysis and theoretical modeling to actually understand what are the mechanisms that drive different kind of collective behavior in social systems. So collective knowledge building is not just the interaction, but actually these are meaningful interaction between people. It's a social cultural process which takes place through self-organized dynamics. Social systems are always self-organized. And we developed a methodology or approach that actually can help us to understand better these kind of processes, okay? And so what we have done, we use the data from stock exchange question and answer site mathematics. These are very high temporal data. People interact through answering questions, to asking questions, answering questions, and often commenting questions and answers to better understand what the person asked and better understand how the answer is. And what is a nice thing in this case, what we used was that the fact that questions are tagged. So there is a predefined list that grows, of course, of tags, and each question can be assigned up to 5 tags. And using this information, we can actually study how we build knowledge in one community. So the data was used, the span of the data was about 4 years. And as you can see, we had almost 100,000 people that asked almost 270,000 questions, almost 500,000 of answers, and there is more than 1 million of comments and on both of these questions and answers, okay? So what we do, we use these data to map them on bipartite networks, where basically we have one partition of users and the other partition consisting of questions, answers, and comments. These networks are interesting because they kind of shows us how people interact through these archetypes, which are questions, answers, and comments. And besides, we can use these bipartite networks to project them on user or question and answer partition and study the structure of these networks. These structural properties actually can show us different kind of features for these systems. Besides this, we also develop different kind of agent-based models. In this case, we actually developed agent-based model of two types of agents. One are users and the others are questions. And user agents actually had this prominent feature of expertise. So we wanted to test how different kind of number of expertise and different distribution of expertise actually influence of knowledge building in one system. And we used many information from empirical data to actually calibrate this model and study its dynamics. What we found out is that these are two laws that are typically studied in our systems. This is Hip's law and Zipf's law. Hip's law actually shows us how the knowledge grows, or the size of the knowledge base grows with the activities in the system. So on N, we have number of questions asked, and on this DN on the y-axis, we actually have how the number of different tags grows and how the number of combination of these different tags grows. This is Zipf's law shows us the ranking of frequency of both tags and their combinations. And actually, what is an interesting thing here is that if you look, for instance, for innovation, so in patent system, you get the same laws with a very similar behavior. So what this shows us is that we actually innovate not through introducing new technologies or new tags, but we actually innovate through combining already existing technologies into new combinations. And this is also the thing that you can see in the patent laws. So this is something more typical for social systems than for the specific question and answer systems. Good. Also, social systems are self-organized criticality systems. This means that they have this avalanching behavior. And these avalanching behaviors, we didn't just observe in collective knowledge building. Actually, you can also see. What we found out is that the number of expertise does not influence this self-organized criticality that is observed, and all these behavior actually have these long-term correlations that are typically occurring in many and most of the social systems. So it's not related to expertise. What is related to expertise is actually how we build networks in these knowledge systems. And we actually used our model to test this. So basically, when you have a single expertise network, then you have very these specific islands of groups of users who group around specific expertise, so they don't interact with each other. If you have two tag expertise, then there is more mixture between the community. And then we actually tested on a random network. So when the expertise doesn't play a role, who is going to answer which question, and then you have totally different networks. So basically, what makes an important thing in this knowledge building system is how many expertise and how they are distributed in the system. So just to conclude and summarize, I think I already told you, but we innovate and discover knowledge by making new combinations. So we rarely introduce new technologies. And what is an interesting thing is that not just in innovation thing, but also when people, for instance, discover new music tastes or new novelties in music, you see the same pattern. So this is something, a social thing. It's not related to specific system. It's a long-term correlated process, and it's very persistent. So it's also social. And of course, where the expertise plays a role is actually in these bipartite networks. And this is where we should search. Okay, thanks.
Thank you. Okay, thank you to all the speakers. We have now some 15 minutes for discussion or questions. So is there some specific question some of you would like to ask here? Okay, and then
yes, just briefly, I wanted to thank all the speakers. I thought these were some of the strongest talks that I've been to today. I have multiple questions. I want to limit myself. I wanted to ask very briefly on social media addiction. If you're using the same diagnostic that you would use for other addictive disorders, are you also using similar interventions? Basically, what's best practices as far as interventions for social media? And then on the last, very briefly on this last talk on the network analysis, what were the data sets you were feeding into this? I was a little bit unclear if this was pure modeling, or like would this apply in natural science, social science, other kinds of innovations? How does this differ from the standard diffusion curves and other things we see in network analysis? So the empirical component of it. Thank you.
Okay, so if you're asking me as a psychiatrist, how do I actually diagnose and treat social networking addiction? The honest answer is that I don't, because social networking addiction is not formally a diagnosis according to international disease classification. So I cannot actually make that diagnosis. I cannot make someone go to a leave. I don't know how to say it in English. So give him leave of absence from his workplace because he actually has a social media addiction. However, it's a phenomenon. There aren't the official diagnostic criteria. So what we actually did is we took the official criteria for addiction in general, and those criteria in psychiatry are used for alcohol, for drugs, for heroin, cocaine, for narcotics mainly, but they can be applied for any sort of addiction. So loss of control, craving, and neglect of obligations, personal or family or work obligations. So that goes for any kind of addiction. So we made that part of the questionnaire. Those questions exist, but we just took them and applied them for social media.
Okay. So I don't know if I understood the question well, so please. Okay, so we use Stock Exchange data set. So this is, Stock Exchange is a huge network of question and answer sites. If you're a programmer, there is a Stack Overflow, which is very familiar, but they actually have more than 150 other sites where you can actually study how they build this knowledge in different fields, okay? And actually, it's a very nice data set that we use. We have a paper, we are waiting for review results about collective trust. Actually, you can also use it for that. But this is empirical analysis, and then based on this, we actually develop an agent-led model. And we use both of them to understand the process.
Okay. So we had a question here in the first row from Damien. Can you, you're just gonna wait for the microphone.
Thanks a lot. Well, I think I would have talked a lot about with Maria and Sarah, because I found both really interesting to yours as well. But those of you were very close to what I also find very interesting. But I actually also have a question for the first presentation, because, well, I know relatively little about it. That's why I have a question. And that is, I was wondering whether you considered the possibility that the causal direction could also be the other way around to at least some extent. So could it be that you basically, because you suffer from some stress, you basically, as some kind of escapism, are drawn much more to social networks, so sites or other online things, you are then maybe getting stuck there and develop those symptoms of not being able to switch off, or what was in this questionnaire. But well, you are the expert on that domain, so that's why I'm asking whether that actually makes sense or not at all. Yeah. Thanks.
Thank you. So in psychiatry, as in psychology, it's sometimes very difficult to make a causal relationship. So what we actually, most studies do is it's a cross-sectional study, which means that we determine that there is a correlation between, for example, social networking addiction and depression. So that can mean either that social networking addiction caused the depression, or that depression caused social networking addiction. So we don't know what is true. Perhaps someone is depressed or anxious or under mental duress. And as a result, he has some kind of tendency towards isolation and spending a lot more time on the internet. On the other hand, someone may have a social networking addiction as a primary disorder, if you can call it a disorder, and as a consequence, you have depression or some other mental problem. So the honest answer is that we cannot know that, but there is a connection. So there are numerous studies, including our own, that found the connection that the more time you spend on social networking and on internet in general, on your mobile phone, smartphone, the more likely is that you will have either depression or anxiety disorder or a mental distress. So that can be quantified. So there is a statistically significant correlation, but we don't know causal relationship. If we want to determine the causal relationship, we would need to make a prospective cohort study to follow up a large sample and over some period of time, and that would be very, very difficult. There are very rare studies like that because this is a relatively new phenomenon.
Thank you. So, any more from the audience? Okay, here we have one.
I'd like to ask, it's still in the social media addiction aspect, on regarding to particularly, I know this was not part of this study, but just on your knowledge in general, on intentionality of the platforms itself to feed into that addiction. Because I think there has been some discussions about whether the social media's quote unquote juice your addiction to keep you in the platform seeing more ads. And then some people were even saying this is even bad for business because long-term an addicted user is a bad consumer. So they would potentially have the incentive to not make that happen. But overall, you know, on the other side, so not on the user side, because I just wonder whether like this is an incidental thing, like when you are anxious and then you do an activity and the social media is there, or whether there's intentionality potentially for the social media. Thank you.
Yeah. Okay. Thank you. So actually, I don't know. So whether it's intentional or not, it's the fact that the more you browse social networking sites and the more you look other people's posts and pictures, the more you get the false impression that other people are better than you. So because people tend to put various things on the internet in which they how do you say that in English? They present themselves in a better light than they actually are.
They overestimate.
Yeah, they overestimate, or simply they lie. That would be an honest way to say it. And we know that most of those posts are either photoshopped or simply we take, I know, 100 images and we select the best one and we put that best one on the internet. And we know that most of those things are simply not entirely true and they are made up to look better than it really is. But nevertheless, our brain, when we constantly browse and look at other people's stuff, we have that false impression that goes deeply, I know where, to basal ganglia or subcortical structures, whatever. And as a result, we have that impression that people are better than us, better looking, that they're even more than us, or even more intelligent than us, whatever. More successful, for example, and that sometimes that can affect one's self-esteem and lead to depression. So it's not intentional. I mean, I wouldn't say that it's really an intention from a Facebook or Instagram platforms for you to get addicted or depressed or anxious or whatever. It's just a natural phenomenon. The more information that you get, not only that you get false impressions, but you get addicted to that way of those behavioral patterns. So there is obviously some part of psychology that can provide a solution to that, how on a mechanism how that actually makes sense.
So now I'm going to take over to save Igor for any further questions. I want to first to give an opportunity to Alexander. Do you maybe want to add something that you find that there wasn't no time to with Sarah's presentation, or just any comment to what you heard?
Yeah, well, first comment is that all talks were really interesting, and I think they're also connected in some way, and it's just an example how a research community in a small country can produce research that has some connecting lines from different disciplines, that, as we have seen today. As for our work together, this should be treated as a pilot study, as a early stage research. There is lot of work to do. This is just the thing I found most surprising about these results is how clear the differences are, given that the data sample is small, and that emotion detection is a noisy process. So I was afraid that we were going to lose all differences between populist, non-populist, that everything's going to be one flat line. But it seems that given a small sample, we can observe pretty linear relationships between emotions and degree of populism. We hope, of course, that difference is gonna stay visible as we increase sample size, and maybe one thing to emphasize, why do we go through all this trouble by looking at video instead of text, is that we're not dependent on language. So text analysis is English-centric. For the most part, we can make a truly global sample. The only requirement we made is that the politicians have to come from a democratic country where public presentation, self-representation, and competing in campaigns, elections makes sense. So that was our only geographical, I think, limit. So, but we can, wherever we have democracy, wherever we have competitive elections, we can use the videos and we can process them and analyze them. So that's a lot to do for future work.
Thank you a lot, Alexander. I want to use your topic to actually ask one very general question of all of you. So I'm not a medical doctor or a physicist or an engineer. So, but I do, and my institute does think about these issues from the perspective of social theory and philosophy and social science. And Maria mentioned something which is for me a key point, like what is the data that we are putting into these very powerful models, which are getting powerful day by day. And listening to your lecture, we have these concepts such as populism, now a democratic country. So we know that we have the definitions are not something which is so clear-cut, so easily distributed. And in this sense, my question is, are we ready as a society with the knowledge that we have, with the meaning that we have, with the data set that we have, or the capability to make them and to use this kind of technology? And what is awaiting us in this sense, if the answer is perhaps no? So does anybody wish to comment?
Well, I mean, okay, I'm on Twitter, okay? So every 2 or 3 months, you have these big, large language data models that are accepted by general society as something that it's going to solve all of our problems, okay? Luckily, there are scientists who really push the limits, and they are ready to say, no, this is not true, okay? Actually, with these large language models, there was a huge scandal 1 or 2 years ago in Google where they drop out the whole AI ethics team because of this. Okay, so they continue, but I think both of the scientists who led this team, one is, I think, a law professor, the other is a computer scientist. They kind of created the whole community around them. And I think now we are more aware of the problems that exist than we were aware like 3 or 4 years ago, okay? So in that sense, I think we will fight and we will win. Okay, that's my feeling. Yes, okay. But we have to fight. If we don't fight, then it's going to be a huge problem. We currently have a project that is related to autonomous driving. if you listen to, I don't know, Elon Musk, Tesla and others, we already have an autonomous driving vehicle. That's not true, okay? We are far away from it. And there is a question whether we will actually have, in the end, something that will be real autonomous driving. We will have systems that will help us, so assist us to drive better, to be better drivers or more careful and so on. But there is a huge question whether we will have this, okay? And scientists are actually already realizing this and working on this and so on. So I think it's a kind of fight thing between general public and scientists.
Okay. Okay, so we have some, please.
I don't know if we have enough time to,
Okay.
Because it's highly tied to what Alexander said and you, Vera, said just before, and it's relative to automatization in when we measure something. There are historical precedents that are clear with this respect. I think, for example, Sir Francis Galton, who tried to measure, criminal attitudes based on physiognomy, or Dr. Charcot, who invented hysteria because, and the problem in that moment was positivism and photography, because once you present something and you capture with the instrument doesn't actually measure something, but quite creates something. So, and you said at a certain point that your database is not so much, it's not so rich, you have not so many videos, and you were afraid that because of the situation, maybe the measure was, I am afraid that is the opposite. The less you get, the more the differences arise. And I wanted just to ask what kind of measures you adopt to reduce biases of any kind. So
that was unfair. So you didn't really reflect on my question. You put there one of your own. So I'm going to ask Alexander and Sarah to maybe bring them together and very shortly.
Well, it's a question about data sources in general. So far, no bias control. The only thing that you can interpret as a control for bias is that we had no context about these videos. So, for example, okay, you have some context when dealing with USA, but there were politicians from India, Brazil, all over the place, where we are selecting content on a strictly objective criteria. Well, let's take the 5 most viewed videos on YouTube from that party. We have nothing, no contextual information, and let's see what we see as an output. So in that case, I think we could not pre-select the videos in order to create these differences, but as that will be more apparent or not in the larger sample. But the lack of context, in this case, I think it's a positive thing for our work.
Okay, so Milan, Igor, do you have maybe some input? I know it was pretty abstract, but maybe how do you see maybe these biggest challenges in terms of what your discipline gives you, and then what this technology?
I can tell you as a psychiatrist, I really I'm a bit disappointed at the technology of artificial intelligence. I have become disappointed over the past several years. I had great expectations maybe 5 years ago from in terms of that I expected that the artificial general intelligence is just across the corner. But what I have seen, at least from my observations and from my impression, is that a lot of that that is presented as artificial intelligence and machine learning is in fact applied statistics. So we just have a computer program, a model that applies relatively advanced statistics. It puts it into a black box and gives you an output after you train it. Whether it is applicable, or of course, when it comes to narrow artificial intelligence for relatively simple things, even more complex things like diagnostics in medicine for some diseases. But when it comes to some fundamental, more complex aspects of human behavior, cognitive functions, etc., I'm really a pessimist. I haven't seen anything that would really give me hope that something will be achieved with that to really benefit humankind. Of course, I may be wrong. I'm really not a computer science expert. I have some expertise in programming. I know Python. I know how to create a model. And I am a medical doctor, but I don't have that kind of expertise that can predict what will happen in, I don't know, 10 years or 20 years. Yeah.
Sorry for cutting you short. Milan, please, just very short
sentence. I'm not pessimist. Personally, I'm not pessimist in that direction, but I think we have a lot of work to do in the future regarding all of these things. We have a good contribution of AI in some part of the society, but there are a lot of bad things regarding AI, and I think we really have a lot of things to do in this direction. Maybe after 20 years in the future, we can have good results in some part of the society.
May I just comment? We are self-organized criticality system. This means that most of the things we cannot still predict. Okay, so
Yeah.
This is actually a great closure for this day, because tomorrow we will see how these issues are thought through by decision makers, by the industry actors, and how we as scientists can interact with them. So yeah, this is one great big experiment. Thank you a lot to all of the speakers here. Thank you to all of you who were with us through the entire day. I remind you that tomorrow our program starts at 8:50, but you can join us for 8 o'clock already for a coffee. So thank you, everybody.
thank you.